Alright guys, Mr. Stair here. Just a quick video here for Wednesday. Obviously I'm coming to you from home with my son being quarantined from class, so I do expect to be there back on Thursday and Friday with you guys. So that being said, here we're taking a look at the next section of the notes. We're going to be doing a lot of factoring. Remember we did that PowerPoint activity on Monday or Tuesday with kind of the matching that we did with PowerPoint. Again, just a reminder, make sure you get that submitted as a screenshot so I can see all 4 of your slides to OneNote. If you're having an issue with that, please get a hold of me through office hours or Thursday in class, Friday during class, tiered intervention, something like that, so we can get it worked out here. All right. What we're going to be doing today is factoring. That's one of the things that we're going to be doing. Another thing that we're going to be using is Desmos. So Desmos graphing calculator is the graphing calculator that I have given to you on my Canvas website. So there's the link for that as well. All right. I'll explain to you when we're going to do each method, and we'll go from there. All right. So here we go. We talked about vertex form. We've talked about standard form. Another form, or a third form that we look at, is factored form. Okay, and that's what this is right here. Y equals GCF. That's what A is, a GCF, and then X minus a factor, and then times the quantity of X minus a second factor, right? And again, A is still that same value in standard or vertex form. So we've looked for that a couple times. It's going to be the same value here. So if I looked at an equation in standard form, vertex form, and factored form, they would all have the same A. All right, so here's an example of that. We could see that in factored form, you might say y equals 2 times the quantity of x minus 4 and x plus 7. Again, it doesn't always have to be minus sign, but recall that's what we did with factors. We had some positive, we had some negative. All right, this is not an example of something in factored form here. All right, so if we're looking at maybe we see 5 equals x minus 4 and x plus 6. Okay, that is not in factored form right here. This is what makes it a no. Okay? All right. Now, the reason for us doing this factoring is because it gives us a very key feature of the graph. Okay, or if we were to graph it, factoring is actually another way to find some points on this graph. So just to remind you, we can either see no x-intercepts, 1 x-intercept, or 2 x-intercepts here. All right, and recall, those intercepts, they're just a synonym for this phrase right here, 0 of a function. Okay, a 0 of a function is where the graph crosses the x-axis. Again, basically what that means is that the y value, oops, can't spell the word value, the y value is 0. That's what it means, again, to be an x-intercept, to be a 0 of the function. Remember, roots was just another synonym that we used. All right, zero product property here. When we're looking at the zero product property, what that means is the equation is factored and 0 is plugged in for y. Now, why might 0 be plugged in for y? The reason for that is because that's when the x-intercept actually occurs. All right? It actually occurs when y is 0. Right here, 2, 0, y is 0. Right here, 1, 0, 3, 0. Y is 0. So that's what we're going to use when we do this zero product property here. Okay? Now, the first step is we're going to factor it. Okay? Now, the difference here is that there might be some equal signs. So the first thing we need to do is to make sure that we get the quadratic equation equal to 0 So we can use this zero product property. So here we go. Letter A. See how it's already equal to 0? We don't have any work to do. Again, basically what that means when we set it equal to 0 is just get it in standard form. Get everything on one side of the equal sign, preferably when A is positive. Alright, so I'm going to go ahead, factor it. Notice I'm keeping this equal 0 here. This is an important feature. Okay, and we'll come and talk more about that here in just a second. So I need two numbers that multiply to be positive 6, so we know that they both are going to be the same. They have to add to be a negative. So it should be x and x makes x squared, and so it should be 3 and 2, and yep, that works out. Now here's what the zero product property has, because this is something that we've done before. At least, I'm sorry, up to this point is what we've done before. The zero product property, this is really a multiplication sign between here. What that means is, I know that something times something equals 0. And the only way to get 0 by a multiplication is if at least one of these are 0. Now maybe both of them are, but at least one of these x numbers makes 0 in the parenthesis. So that's what I want to do. I want to say, I want to know when the first parenthesis equals 0. And I want to know when the second parenthesis equals 0. So therefore, x equals 3 and x equals 2. If I were to graph it, those two numbers right here at 2 and 3, let's see, this one is 2, this one is 3, that would help us determine, and I know there's a lot more to this, but that would help us determine what the actual graph looks like, okay, because it crosses at 2 and 3. Alright, here we go. Let's do 3 more of these. When we're looking at this here, we could see that we're trying to factor. Please don't forget, remember these first two, I know I didn't explain it this way, but again, the first two, they have to multiply to be the beginning here. And the last two, right here, they have to multiply to be the end number. So it has to multiply to be 12. There's a lot of possibilities here in order for it to be 12. I realize I did not grab something here. Give me 1 second. Here it is. And so it could be 4 and 3. It could be 6 and 2. Now, we didn't really come across a problem like this, but here's what I know. I know that 4 cannot go in the first parenthesis. And I know that 6 and 2 can also not go in the first parenthesis. Here's the reason why. The reason why is if I put a 4 there, there would be a GCF in this first parenthesis. And there's no GCF in the original problem. So what I'm going to do here is I'm going to realize that any parenthesis here, whenever I'm factoring it, cannot have a GCF provided that the original problem doesn't have a GCF. Okay? So I guess, what was that, third period on Monday. I'm not expecting third period to remember this, but I tried to do one of the problems, and I almost said this statement. I think it was the second problem that we factored, but I forgot to check to see if there was a GCF in the original problem. Okay? So there's no GCF here, so I know that there can't be a GCF in either of these parentheses. So I'm going to use that knowledge here and just put a 3 first and a 4 second. And then when I actually multiply them, it does make 11x, which works out. Okay? So again, I've just factored it. Now I need to do my zero product property here. Okay? My zero product property again states that this right here, 2x plus 3 equals 0. And so x equals negative 3 halves. Again, if you need to see that, I just subtracted 3 from both sides. And then divided by 2. And then my other one is just x plus 4 equals 0. And x equals negative 4. So those two places are where the x-axis, the x-intercept, sorry if I'm covering that up there, the x-intercept here actually can occur. Negative 1.5 and negative 4. All right, let's try letter D here. How would I go about factoring this? Okay, we forget about this all the time. GCF, greatest common factor. Right there it is. I got my GCF. So now I know that x could be 0 and x minus 4 equals 0. Again, I'm putting each factor equal to 0, even if it's not in the parenthesis, even if it's a GCF. Now, if my GCF was just 4, it really doesn't make sense for me to put that there. But because it's a variable, I know that it could either be x equals 0 or x equals 4. Right there. Okay? Again, those are the two places that the graph would cross the x-axis. If I did, because I do have a little bit more room here, if I drew a quick sketch, it looks like this. Here's 0, here's 4, and it looks like the graph kind of comes something like this. I'm using a little bit more knowledge to graph this than what I'm showing you, but just kind of giving you a representation of what those numbers actually mean for the graph. All right, last one we're going to do here, letter C. It does say to make sure that we get it in standard form, so that's what we want. We want to set it equal to 0. When we do that, we always want to keep the x squared term positive. So notice, I moved it over. We're going to factor this. Two numbers that add to be negative 7, but multiply to be negative 12. And so we got x equals 4 and x equals 3. And those are my two answers right there. All right. So part of what we're going to see here, you might even be starting with the parentheses on some of the Math Excel assignment here. Okay, you might be actually even starting with something that you have to get in standard form first. So there's a whole range of things that I want you to do. Please pay attention to the guides that I'm giving you on Math Excel. If I'm asking you to put something in the show work, please do that. If I'm asking you to use a tool like Desmos, please do that. All right. Speaking of Desmos, that's where we're going to be going right here. I have on a second screen Desmos pulled up. It's actually just here on my iPad. And so I'm going to use my iPad on Desmos, but I am not going to coach you necessarily how to use the website. I'm sure that that's probably happened for you guys, that you have made yourself familiar with it, which is a good tool to use. Let me pull it up here. We're not going to actually be sketching this graph here, okay? But when we look at this, I want to make sure that we know how to put this in here, right? So in this equation, 2x squared plus 7x equals 15, if I just were to write that in there exactly like it shows, there's nothing that's going to be helpful for us when it is written that way. If I zoom out, it doesn't give me a parabola. Here's what I have to do. I have to put it into standard form first. Okay? And because I'm graphing it, I don't want 0 equals. I want it to be y equals. So I'm going to move the 15 over. 2x squared plus 7x minus 15 equals y. So let's go ahead and on Desmos, we're going to make that change. Hopefully you're doing that as well with me here. Maybe you want to zoom out and you could say, oh, you know what? That actually does look more like a parabola. And what I'm doing here is I want to make sure that I know exactly where this graph is crossing the x-axis. Maybe you want to actually click on the graph. In my case, mine is a red parabola. Yours probably is not that case. So it looks like my x-intercepts are at negative 5, 0. Remember, that's a point. That's one x-intercept. And the second one is 1.5, 0. All right, so that might be one way to show it. Another way to show the answer to the same problem here is by actually listing it. So they might say on Math Excel, find your x-intercepts, and just make a list of them. When we list answers, we use commas. So -5, comma 1.5. Notice there's no parentheses here. No parentheses when I'm just listing x values. If it was an ordered pair, I definitely would. All right. If it is just x values, put a comma between it. No parentheses, no brackets, nothing like that. No grouping symbols. Please read the blueprint on each problem to know what they're asking for. Are they asking you to list it as a point, or are they asking you to list it just as a list of values? All right. So that's all the video that I have for you today. Use this video, use Desmos, use the factoring, take a look at those clues that I'm giving you on Math Excel to complete this assignment. All right, guys, I will see you on Thursday or Friday.